I made many thoughts how to start this talk, and to be honest, I haven't found the words to express the feeling that I have right now. I'm first time on Lucene Revolution, and I got the chance to talk about the system that we built in my company in the last 5 to 6 years. The system is based on Lucene and Hadoop, and more precisely in this talk, I'm going to talk about analytics. If you know what OLAP means, you can ask yourself, what is the heck? OLAP is already online analytical processing, and you have already analytics. That means I have in a title 2 times analytics. Well, what I want to point out that the first analytics is how we are using the queries to constantly improve the system. And I try to collect all aspects, how we are mining the queries, and I'm going to present the results in this talk. So I'm going to structure the talk. I'm going very briefly to introduce my company and me, and then I'm going to present the big picture of the system. Afterwards, the most of the time, I'm going to spend on analytics, and finally, we have to have some times for questions because we have a book to give away. What about my company? My company is zanox, and that's an affiliate marketing company. Companies bringing together advertisers and publishers. Advertisers are online sites that are selling products, and in order to sell products, they need traffic, they need visitors. And on another side, we have publishers. Publishers have blogs, they have traffic, that means they have visitors that are reading the stuff, but they want to make money with the content. And what zanox does, zanox is bringing together thousands of advertisers with millions of publishers. And what is unique for zanox network, it's performance-based. That means advertisers are going to pay commissions to publishers only when they are earning money. That means only when the visitor bought something. In the heart of that system is reporting, and reporting is providing information to advertisers and publishers how they are performing. That means how many sales, clicks, page impressions viewed happen in a given time period. What about myself? I have some experience in using Lucene, many years of experience, and also many years of experience of using Hadoop. As I started with Hadoop, it was the version 0.15, and there was no such thing like a Hadoop ecosystem. It was necessary to develop all the components by yourself. Now it's like a paradise, and you have books. In that time, you had only source code that was not so well documented to figure out how MapReduce works. And from recently, 2 years ago, I started to use also HBase, and I hope on the future conferences I'm going to report about how reporting with Lucene or Solar compares when we use HBase for reporting. I had PhD, and during the PhD, I learned a lot about machine learning and how you can use machine learning to optimize resource usage. We are going to have in the talk a little bit about machine learning, but you shouldn't be scared. You don't need to be the freak to understand what is going on. You have the beautiful tools, and you only have to feed the data in the tool, and the tool is doing everything for you. And I'm trying to improve my profile on LinkedIn. And in general, I'm happy if you can send me the feedback about the presentation and any questions to my email address or via LinkedIn. If we are taking a look from 40,000 feet, that's right, that's where airplanes are flying. We have few boxes. On the left-hand side, we have the boxes tracking and custom, and they are providing the data. MapReduce is responsible for crunching the data and generating Lucene indexes that are fed in the distributing reporting that is serving the user requests that are coming from JBoss applications. And let's make a deep dive into the different components that we have there. We have a searcher, and searcher is one building block. It is a Lucene searcher that has aggregation component and query optimization component, and we put that in one remote procedure call server. And because I have so much space in distributed reporting, I have not only one searcher, I have several of them that build so-called searcher group. But this searcher group I'm going to explain in analytics part of a presentation. And I have several groups. And in order to coordinate the searchers, I have one merger who knows, it is important for right now to understand, he knows the capabilities of different searchers, and he knows which searcher is the most suitable for the query at hand. Finally, somebody is saying, okay, you have a single merger, single point of failure. Well, we have in a cluster also so-called observer, and he is doing checks if everything is working correctly in the cluster. If merger is refreshing the knowledge about searchers, for example, if all searchers are correctly responding, and if something is necessary to be fixed, observer is fixing that. And finally, we have a few more clusters. Even though I have the same structure of each cluster, it is not necessary that each cluster has the same groups of searchers. Who is using the services of mergers? And those are the clients, and clients are different JBoss applications. That means our reporting system is not client-facing application, but we built in the company different other applications that are using report service in its core. Several clients are available. Finally, let's fill the block tracking and custom. Tracking is responsible for collecting events like sales views, clicks, and so on. And that's a proprietary application in C++, and we have several tracking servers. Finally, the data is to be found also in different databases, FTP servers, log servers. They are all also providing the data. And the last but not the least important, we have the data from search engines and that are providing the cost information that are also landing in our Hadoop cluster. We know that Hadoop has a potential of storing petabytes of data, and we thought, okay, everything that we have, we are going to put in Hadoop, and let's see if we can do any good. In the middle, we have different Hadoop jobs. And now I have one animation because I know that one animation is worth as 1,000 pictures, and that animation is going to show you how the system works. During the whole day long, all the systems are simply pushing the data in Hadoop. In Hadoop, it happens nothing. It means whole day around, we are not doing anything in Hadoop. And then at midnight, we are starting the Hadoop jobs that start crunching the data, aggregating, joining, computing different KPIs, and so on. And approximately 6 hours later, we produce Lucene indexes that are going to be sent to the search cluster. Observer in that search cluster is going to check if everything is okay with the index, and is going to inform the other clusters to load the index if everything is okay. And approximately half an hour later, we loaded the index that were produced during the night. What is happening with the query? Clients are submitting the query, and they're submitting the queries to the merger. They're picking the merger based on the load, but let's say merger is not accepting the query because he doesn't have right searchers. Another merger is going to be chosen. He's again analyzing the query, and he's going to submit the query to the right searchers. Searchers are going to process the query, to load the data, produce the sub-reports that are returned back to the merger. He's putting all the stuff together and returning the report as a rule in a sub-second time to the client. Let's sum up reporting in general slide. It's very, very important. Okay, that's something that I already mentioned. But here it's very important to notice that we have not real time. Real time sounds cool, but we don't need here real time. And we are focused on crunching the big data with Hadoop and producing once a day index that is fed to the search cluster. And today, I'm going to talk about analytics. Analytics that helps us build better indexes. and help us optimize the queries and make each query performant. Okay, that's going to be the heart of my presentation, and I split it in 3 parts: searching, sharding, and optimization. And if you are bored, you can track the progress and you know when it's going to finish. But about searching, on the first few slides, I'm going to show you how we are intelligently putting the data in Lucene index. I haven't seen a lot of talks about how you are going to put the documents in index when you are storing the data in index. And here in our application, it's very important to wisely store the data in Lucene index. And I'm going to briefly illustrate that. But those are the data that should be stored. I have 4 columns: name, date, advertiser, keyword, and publisher. And in OLAP terminology, those are so-called dimensions. And I have also 2 other columns named commission and amount. In OLAP terminology, those columns are called measures. And we're going later to see that we don't have only a few dimensions and few measures, much more. But I hope that this example is going to illustrate what we are doing. And the first question is how I'm going to store the measures, commissions and amounts. Okay, trivially, I can define the commission field in each document, amount field in each document, and store the values. But maybe I can do something better. I want that the data that is stored is as small as possible. And in order to have a better compression, I want bigger fields. Okay, but I'm asking myself, which fields should I put together? For that, I'm using analytics. I have queries, and I can analyze the queries and see which measures are always used together. And if we are trying to put some machine learning phrases, that's something that is called frequent set mining or frequent pattern mining. And there are many different approaches for doing that. A priori is a standard, but it is a slow one. But there are there are other approaches that are much faster. And I'm saying you don't need to understand how each approach works. You have, for example, in Mahout, parallel frequent pattern mining, and you only need to feed the data, and he is giving you the frequent sets. And frequent sets means, okay, those measures are used together. Let's put them together. Instead of having 2 separate fields, I will have 1 field that has both measures together. And if you think that you have not only 2 measures but much more, you can have the effect that you can have a slight gain in the compression. But we were not happy what we achieved. We were thinking, okay, what about dimensions? I have a lot of dimensions. How can dimensions help us have even bigger fields? Okay, when I'm saving the dimensions, I can say, okay, I am using 1 dimension as a filter. I don't need to save that. I'm going to read the values from filter cache, from field cache. That's good. Okay, when I have a special dimension like keyword, by the way, that motivated us 6 years ago to use Lucene for online analytical processing, because Microsoft tools were not able to do text search on a dimension. And in our OLAP, you can search, you can build a report and say, I want that in keyword field, word insurance is there. And that, because we have Lucene, is piece of a cake. It works. I have some dimensions, maybe, that are never used as filters, but only as groupers. What does it mean? I have a dimension that always when I need the values from that dimension, I need all of them. That means I don't need to filter. Okay, I won't index the field. But I'm saying we can do something much better. We can put that dimension inside the commission and amount here. That means if I have assumption that publisher is a dimension that is almost never used as a filter, that means I am always using and accessing all the values from that dimension, I'm going to build even bigger fields. And here, if you think that that publisher dimension has a huge cardinality, here I don't have only 2 values. Maybe I have 5,000 of them. And that's great when you are compressing. You are producing the index that is maybe for 1 order of magnitude smaller. And if the bottleneck is loading of the data, you speed that up 10 times. That was amazing. I proved that PowerPoint is not scaling well when you have a lot of moving objects. But go further. And that means query is coming, and I want to show what is happening when query comes. And you have to understand that to understand sharding and optimization steps. OK, query comes. I'm not grouping. I'm only saying, give me the data for advertiser hook. OK, let's throw away the fields that are not relevant for this query. I don't need date, and I don't need keyword. I only need the advertiser field, and of course, I need the values. OK, what searcher does? It searches. That means he's going to select the fields, the documents where in advertiser field I have hook. That's normal. That's something that Lucene does. But then it's the important point. We have to load the stuff. And when you are doing relevant search with Solar, you're only asking for 50 top or 100 top ranked documents. In this case, because we have reporting, we have to load all the hits. That means if I have 50,000 hits, I have to load all 50,000 documents. And because of that, loading is the bottleneck. And because of that, we did a lot of thoughts how we can optimize how we are storing the data. 2 years ago, I started analyzing what HBase does. Doing pretty much the same. But 5 years ago, I invented that. And finally, when the loading is finished, he is going to aggregate. And as a result, we are going to produce the report. That means total commission and total amount for advertiser hook. I am finally asking myself, OK, that's nice, but can we do something even better? And the answer is, yes, we can. That is something that we liked in my company. We are always saying, when somebody is asking, can you do that? Yes, we can. The question is, what can I do to make that even better? Well, let's take a look. I have to load the following values. And I noticed that the values that I'm loading are not concentrating around the same doc IDs, but I have them scattered in the index. That's something that I don't like. And as I mentioned, HBase doesn't like that also. I want that the data that I need for a particular query is saved on a consecutive locations. Then when I'm loading them, it's most probably the document that I already filled in a file system cache already there. And how I'm doing that? Well, I'm checking which dimensions are used most often as a filters. Here I have dimension advertiser, and I'm saying, OK, in this case, I was sorting everything based on date, and then based on advertiser. But that's really not so good in this example. I'm saying I want to sort my data based on the filter. That means, again, I have analytics. I have Hadoop. I'm analyzing the queries that we received in the past, and we are receiving around 1 million queries per day, not per hour, but per day, but it's still a significant number of queries. And you can check what are users using as a filter, and simply reorganize your data based on that filter. And because we have Hadoop, anyway, we are building that in batch during the night. That means for the next day, we can have index that is better organized. And we are done with the first third of analytics. And we have in a system 9 dimensions. And we have dimensions that have cardinality that is huge, more than 1 million different values. And those dimensions, in the case that they are also rarely used as filters, are great of being put together in a value fields. What about measures? We have 50 different measures. unbelievable. You have, because of that, Hadoop jobs that are crunching the data, applying different functions and computing something that somebody else maybe needs in application that is client-facing. And those dimensions, because client applications are facing our reporting system, usually grouped very nicely together. That means we have several groups of measures, and we know that the stuff, the measures that you need for a particular query are grouped together. And finally, about the ordering of documents that I'm finding extremely also important, because once we didn't take care and put a filter that was advertiser at the end. Our map and reduce framework scattered the data across the whole index. And we were wondering what is happening right now. And our queries are not anymore in sub-second time, but it took almost a minute. And it was like very hard to detect that it was only a slight change how you were sorting keys that mappers are emitting that made that. And thanks to that, we learned the importance of putting the documents that you need for a particular query together. What about sharding? That was our complete playground with 3 clusters. And when I'm talking about sharding, I'm going to analyze only one particular searcher group. And I have 5 searchers, and I have 1 merger. And let's say that I am using something that is state-of-the-art, sharding based on hashing. That means I'm going randomly to distribute the data across all the shards for advertiser hook. What does it mean? When merger receives the query, he has to submit the query to all the searchers. But we have as an effect, they all have to work very hard. Searching, okay, and quickly finished. But then loading. Some have problems in finishing the loading. And at the end, each one is generating the sub-report that has to be sent back. Here in this example, because I was not grouping on anything, reports were rather small. But when you are grouping on the field that has huge cardinality, your report can easily have 100,000 of rows. That means that effect that you have to send all the reports back to the merger is not so good. And finally, merger has to aggregate to sum all their sub-reports and to produce one big report. That means for merger, when he has to handle a lot of sub-reports, it's also not so pleasant when you're thinking, I have 50 shards, I'm getting 50 sub-reports, I'm waiting that all are there, and then I'm putting them together. To shortly sum up about hashing, here, when I randomly distribute the data, network is not my friend. Actually, I'm very unpolite, and network is something that is a very precious resource here. Because of that, I'm asking myself, okay, and can I generate the same report with less searchers and 3 other searchers for other queries? And I'm saying yes, and the answer is again extremely simple. I'm going to take care again about dimensions that I'm using as a filter. Very simple, but usually good stuff are simple, but you have to know that you have to apply them. I'm saying when the query comes, advertiser hook. Why I have to scatter the data around all the searchers? I can concentrate the data for a particular advertiser maybe to only 1 or 2 searchers. That means when query comes, merger now knows when the type of the data that each searcher has, and he knows that hook is already available in the first and third searcher. That means only 2 searchers are doing the job, and others are not doing anything. Can accept other queries that are concurrently coming. Okay, in this case, maybe processing of each query lasts a little bit longer because each searcher has to do a little more because the data is only on 2 searchers, but at the end, I have only 2 sub-reports. I'm not loading the network, and network is the bottleneck here. And the merger that is also in this scenario, a single point, doesn't need to do so much to put only 2 reports, or maybe it's only 1 searcher that is generating the complete report. And again, to shortly sum up, and that's what I already mentioned, We don't like when we are distributing the query to all the shards. Here we don't need that. We are not computing the relevance. We don't have term frequency versus document frequency. That means it's perfectly fine that you're putting the data that your query needs in only one shard. And I already saw a couple of other talks. They said with that strategy, you are boosting your query per second for 10 or 50 times. And that's something that happened also in our case. That's that point. Okay, let's move to the third part and the last part of my presentation. And that's a small deja vu that I already presented in Zinsheim last year in Germany. And because there are a lot of moving objects, I wanted to give that here also, because that has also to do something with analytics. What we are going to talk here, we are going to talk about whole cluster. We are going to talk about 3 searcher groups, and you're going to learn what we call searcher group. Okay, I have 3 groups, and I'm asking myself, what about these groups? What is so specific in each group? Well, dimensions that are available in those groups. That means in the first group, I have publishers and advertisers as a dimension. That's something like you can think, and that's a huge benefit if you're comparing to the classical OLAP. Here, each group has optimized a particular combination of dimensions. And if he's getting only the queries for publisher and advertiser, the first group, he doesn't need to load a lot, and he is not doing any aggregation on the fly. We are almost there. The query comes, and in that query, I'm saying, okay, do filter based on publisher Jim. Okay, and I can do some query routing, and that's not the topic of today's talk. And here is the challenge to decide which group is the best, where I'm not aggregating a lot on the fly. But let's say I have the Hadoop, I have enough resources there, I can build one more group. And that group is going to have only publisher as dimension. That means I'm doing simple lookups then. And I can keep building other groups. Okay, our IT is maybe a little pissed off because each group means few more searchers, few more machines, but who cares? Or maybe they care, we are going to see what happened here. But for these 3 dimensions, I built all the groups. And I optimized it 100%. That's like a dream when you are talking about online analytical processing. You're finding everything that you need in index, and you are doing only very fast searching. But I'm saying the enemy struck us. Product owner requested one additional field, requested one additional dimension, website. And I'm saying, I don't have the group with website. What can I do? Okay, let's try putting some more groups. IT haven't mentioned that, noticed that, but I'm putting some more dimensions, some more groups. And I'm keep filling and producing the new groups. I have the Hadoop. Okay, he's doing a lot during the day also. But I'm seeing, okay, I already produced 13 groups, and I don't have any more place here on a slide. And maybe there are no more machines available. I'm saying so many groups, but I don't have the group that has the requested dimensions. And here I'm saying, definitely we cannot optimize everything. And here analytics comes to the play. We have 9 dimensions. That means we have so many groups, and think that in each group you have a bunch of searchers. That means that's something like a data center. I'm using analytics, and I'm analyzing the queries to see how each group is performing. And I'm going to remove the low-performing group and to free the resources for the new emerging trends. How that looks like, we are going to see on the next slide. How am I estimating the groups? I'm simply checking how many queries each group processed in the given time period. And I'm also checking the average response time. It means in my case, response time is the feedback that is always available. I can always measure the response time. don't he need the user to say relevant document, not relevant? And here I have the information that I can use to simply find the groups that are not doing so much. Maybe this group here, these 2 queries. Somebody tried, and my colleague, with something and submitting 2 queries. I don't need that group. I'm going to remove those groups, and as an effect, I identified only 5 groups. That means the needed resources are shrinking again. And what does it mean? I have resources to create. Okay, here I'm quickly checking if everything is fine with the groups, and I'm checking which dimensions for which dimensions is each group responsible. And I'm saying, okay, I really don't have a group for the dimensions in a query. Let's build a new group. I have resources, and now my query can be performant. And the loops keeps going. Keeps going means I'm again checking the number of queries, and I'm again checking the average response time, and I'm doing health check of each group. And maybe, like here, I'm noticing that I have a group that is too slow. That means, again, I am going to make a deep dive into queries that this group processed, and to see why this group was slow. That means why average response time was almost a second. What does it mean? On a group level, I'm going to check which fields are used, and I'm going to see how many queries and average response time. And I'm seeing, we identify the cause. I have the queries, publishers keyword, that have the big response time. And really, when I'm checking other groups, I'm seeing I don't have the group that is optimized for publisher keyword. What I'm doing? I'm creating the new group. That's the summary why it's not optimized. And I'm going to create a new group. That's easy. That means you have the Hadoop. He's analyzing the queries. You are detecting which group does nothing or really less. You are removing that, and you are freeing the resources for emerging trends that are continuously changing. That means you have your OLAP that is continuously improving to the queries that are coming. And finally, I needed the last group because that group was responsible also for the bunch of queries. And to sum up the last slide, we improved the utilization of Hadoop cluster. Usually when you own the Hadoop cluster, they're saying utilization is rather slow, rather small, because 30, 40%, and they're saying if you're going to Amazon, Amazon has a lot of clients, and they're going to have spot instances, and they're going to have 70, 80% utilization. With the stuff that we have great utilization. You always define low priority Hadoop jobs that are crunching the data and producing the new, better indexes. And they're always running in a background, and as soon as the new group is available, it's going to be pushed in the search cluster. 10 seconds and I'm done. About query routing. It's not the topic, but I'm saying query routing can either use the heuristic rules, or before asking the searcher to generate the report, you can ask him, please say me how many records you need to load. And if he's saying, I need to load 2 million of records, you're saying, that's going to be expensive, and then you're finding another group. But as I said, that's not the topic of today's talk. And that's it. I'm really happy.
A few questions.
Yeah, I'm really happy that only once I had a block presentation. Okay? Yeah? Okay, I will repeat the question. The question was the optimization that I presented, does that happen automatically? The answer is no. It happens semi-automatically. System is giving the suggestions, and somebody is allowing new groups because IT is our friend. But I'm seeing here that it's a really short way to have that really completely automatical, and that is going to be the great. Okay, the question was how the clients are contacting the mergers and knows which mergers are available and what is happening when merger is not responding. In the time when we did that, there was no zookeeper. We did that in 2008, and we had to do that clients are pinging the mergers and always keeping the list of live mergers together with the number of queries that merger is currently processing. And based on the number of queries, we are saying, okay, the merger that is doing is not so loaded is going to get the query, but he has the option of rejecting that query. Maybe the searcher that is needed is not available, and then client is getting back, and he's going to choose another merger that has acceptable load. And what I don't show it here, maybe all mergers are rejecting the query because query is unbelievably expensive. In that case, we are submitting the query in a Hadoop. It's going to stay there for a couple of hours, and we are going to use map and reduce for generating report, but that's not anymore online. The client is getting information, your query was too expensive. We are going to generate that, and you can download that from the following link in 2 hours estimated. You're welcome.